Welcome back, everybody. Um, I'd like to thank you all for coming again. This session is under the wastewater, and we're going to be looking at the hidden cost of advanced wastewater treatment solids and residuals. Our presenter is Pat Miller. Pat Miller is a certified level 3 wastewater treatment plant operator. She's a level 3 water treatment and a level 2 in water distribution and wastewater collection. Or level 2 in water distribution and a wastewater collection level 1 compost operator. Prior to entering semi-retirement, Pat managed the Sun Peaks Water and Wastewater Facility for the past 26 years. She is still involved in promoting treatment and beneficial reuse of water and solids that treatment produces. In addition to being a past board member of the EOCP, Pat continues a long-term member of the Compost Council of Canada, a national nonprofit organization dedicated to the advancement of organics recycling and the return of organic matter to our soils. I'd like to pass this over to Pat, but just one quick point before we do that. If you got questions, or you use the chat button on the top or the email button on top, we will collect the questions and get them to Pat at the end or in a timely manner and address them. Okay, so I'll pass this over to Pat now. Thank you.
Great, thanks, Jim. Good afternoon, and thanks for attending this session on the hidden cost of advanced wastewater treatment and for EOCP putting this conference on. Today, we're going to talk about some of the challenges of advanced wastewater treatment that should be considered when developing an overall budget as facilities strive to produce even cleaner effluent, but aren't. Most municipal councils and senior staff only focus on dealing with the requirement for effluent quality and forget about the fact that what's going to be left over from the treatment process, and that's going to be solids. Okay. So I'm going to talk about a little bit of refresh your memory on what we get when we do treat wastewater, a short review from conventional to advanced wastewater treatment, and how the plant treatment process impacts solids production, and why municipalities through the consultants should look at the final product and reverse engineer the process to keep costs down and under control. And I'm going to spend a little bit of time on very different treatment technologies and how that can impact the plant classification, and why returning organics to food production areas is so critical to keep our soils healthy. And I'm going to introduce you to a couple of success stories and have a short review of what I hope you can take away from this presentation and provide you with possibly some tips on how to deal with the NIMBY attitude, not in my backyard. And if we have time, answer obviously some questions. So what does wastewater treatment produce? Liquids, energy, and solids. Treatment liquids or effluent can be discharged to ground, surface water, or be reused for such items as irrigation of hay fields, golf courses, or even snowmaking. Effluent can be used in industry processes from fracking to process cooling and a whole lot more. In areas where water is scarce, effluent can be used to produce drinking water. The true recycling of this very valuable resource. Advanced treatment systems can either be net consumers of energy or producers of energy through the use of off-gassing of treatment process or using materials to power generators. What I'm really here to talk about is the organic solid or the spent biomass that is left over from the treatment process. It's these solids that can be a nightmare or a source of benefit to the community. The biggest challenge on how to control non-organics that enter the wastewater stream, you've got two options. One is education on what not to flush, and we're all working on that one, and removal at the headworks. So what happens when you move from a conventional to an advanced treatment system? It's the amount of wasted biomass as the system gets more complex. Basic systems usually include some kind of a storage lagoon for holding the liquid while the treatment takes place to meet the biological oxygen demand or the total suspended solids discharge requirements that allow solids to settle out. And whether you, excuse me, whether you have a simple or complex lagoon treatment facility, it'll collect solids over the years, and every so often you have to desludge the lagoon, usually every 10 to 30 years or longer. And these solids are normally well digested and have little energy, but do have some great nutrients that can be beneficially reused. Historically, municipalities have used lagoons for headworks, i.e., the sludge is going to be full of grit, solids, plastics, sharps, etc., as well as the treatment process. So if you don't screen first, you're going to have to screen afterwards. And if you can't screen, the sludge will end up going to the landfill, which is what none of us want. As you increase the complexity of the treatment process, the quality of the effluent being discharged is improved. So why do we care about the quality of the effluent being produced? The closer it comes to pure water, the more the process takes contaminants out of the water stream. A lagoon may only have to meet 45 BOD, 60 TSS, but an activated sludge plant or other mechanical facility will have to meet lower BOD or TSS levels, as well as possibly some nutrient removal. These targets will obviously depend on your discharge point. And depending on your specific treatment process, you may produce up to 35% of your total flows in wasted biomass on a daily basis. For small facilities, they may choose to hold these waste products for a short period of time and ship them to a larger, better equipped facility, but shipping does cost money. An additional solids treatment is usually added when the shipping costs exceed the cost of treatment on site, or the facility down the road doesn't want your waste anymore. In moving from a simple or conventional to an advanced treatment process, facilities like biological nutrient removal or BNR processes can double the amount of solids produced. Knowing that this increase in solids will happen, the total budget of any wastewater treatment plant should allow for at least 50% or more of the total budget allowance for the treatment of these solids. Does this happen in real life? No. Everyone loves the fact that the new facility will be able to produce really high quality water, but forget about the fact that what's taken out of the water as part of the liquid treatment process still has to be dealt with. Here's a typical engineering diagram. Do you see any allowance for solids? Even if it's shown, it's usually an arrow showing the solids going to waste, but no planning is usually allowed for when budgets are set out. Thus, it's usually the operators that have to come up with some kind of budget and plan for solids management. So how do we solve this forgotten problem? Take the standard scenario in today's regulatory environment. The regulator says you must meet 10 BOD, 10 TSS, 1 milligram of phosphorus, 5 milligrams of ammonia by such and such a date to stay in compliance. The only caveat that the approving regulatory body demands it for solids management is a statement that might say, consider beneficial reuse of solids. Don't send them to landfill. So staff report to council that the rules have changed and they have to upgrade the treatment process to meet these new demands. Council approves the budget to hire an engineering consultant to determine the needs to reach these effluent discharge requirements. And then the engineering consultant comes back with a Class D estimate on what is needed to reach the regulatory requirements. And this is where the process starts to fall down. The consultant was told to meet the effluent discharge requirements, but not to deal with the additional products that are produced as part of the treatment process. So council approves a budget that doesn't deal with the increased solids that will be produced. Or better yet, the consultant does address the increased solids, but proposes the use of a digester to treat the sludge as a great way to make facilities more energy efficient. Keeping in mind, you need a large amount of sludge to run an anaerobic digester. And I'm not knocking anaerobic digesters. It's just they require a lot of sludge to keep them going. So normally only larger municipalities have the anaerobic digester. Many smaller municipalities end up with an aerobic digester, which is an energy consumer, although they do require less capital than an anaerobic digester. By proposing a more complex and controlled demanding component to the treatment system, like digesters or even incinerators, this change will make the facility's classification change from a level 1 or 2 lagoon or activated sludge to a level 3 or 4. It's great for us operators, assuming the facility can find a level 3 or 4 operator. Quite often, digesters and incinerators are chosen because other solids treatment processes have a bad rap. Things like low-cost options like composting smells, or perception out there is the composting process does smell, and thus politicians may choose a more expensive option than risk the ire of the public. According to popular research sites on the internet, I love these ones, everyone believes that biosolids could contain all sorts of bad things like microplastics, brain-eating amoebas, toxic chemicals, pharmaceuticals, and the list of bad things that are contained in sludge on the internet grows every day. People forget that food gets shipped from the rural communities and is consumed in the urban environment. And if we don't find a way to ship those nutrients safely in the form of organic materials back to the rural community, eventually the land will lose the ability to produce the food that we require. So what are our options to beneficially reuse the solids and keep the overall costs down? Remember, the bulk of your sludge or biosolids is water, anywhere from 98.5% to 60% water, depending on what your dewatering process is. So if you want to digest the sludge, you need to make sure you're adding the right components, maintaining the right mixture, off-gassing the methane, and withdrawing the exhausted sludge, which has no energy left. Even after digesting the sludge, you still have some solids to deal with. Alternatively, if you're going to incinerate the sludge, as some municipalities are considering, you'll still have to get rid of about 60% of the water content, and that takes a fair bit of energy. Well, in places like Arizona or New Mexico, the sludge can be laid out to dry, but that's a little more challenging in BC, especially in the fall or winter. And what you might save in capital costs, you'll definitely spend in operational energy costs. So again, what are your options? So the real reason for this presentation and why composting wastewater biosolids works. Remember, the bulk of the biosolids is water, anywhere from 98.5 to 60% water, depending on the dewatering process. But to compost, you actually want the biosolids about 25% solid. And you can mix it with other organics like wood chip, kiln waste, or chopped up organic matter. It's a natural process, and it works well with little intervention, and the system can be self-managed. Excuse me. And it's great for small facilities, and it can be simple to operate, doesn't require a lot of labor, or it can be automated for larger facilities. Remember, I talked about facility classification hitting the higher levels for facilities. EOCP currently doesn't count composting as part of their wastewater treatment classification model, but digesting and incineration does. Hopefully Jenny doesn't make a change in the model. Remember, wastewater does produce odor all the way from the bathroom to the pipe belly, to the lift station, to headworks. And each area has different methods of successfully controlling or eliminating those odors, including the composting process. Public only complain if they're impacted, so be proactive when dealing with any odor issues. Remember, odor control systems for compost can be simple and inexpensive. So, on to some success stories. All right, TransAlta operates the composting facility located just outside of Moncton, New Brunswick, and has the capacity to process 30,000 tons of biosolids and amendments. Right now, it processes approximately 10,000 tons of biosolids, plus an equal amount of amendments that they divert from landfill. And they produce about 8,000 tons of finished compost, of Class A compost each year. It uses a bottom aeration system and a breathable cover, and the process takes 2 months before the material is moved into a curing area. The system is designed for the Greater Moncton Wastewater Treatment Plant, is extremely efficient and very energy conservative. The process is outdoors under covers, and it generates its own heat. Positive aeration is done intermittently using small fans and very little energy. Temperatures generally in the windrows reach 70 degrees Celsius and generally stay well above 55 degrees for the 2 months during active composting, when it's generally turned 3 times. The biosolids come from as I mentioned, the Greater Moncton Wastewater Commission's wastewater treatment facility. And it uses a chemically assisted primary process that's being modernized to a BNR facility. The sludge is extracted from the primary tanks and conditioned with lime and dewatered to approximately 30%. The biosolids are then transported to the composting facility, where they're mixed from bark with local sawmills, ground green waste received from local tree trimmers and landscapers. And the ratio that they use is generally about 50-50. And the finished product is made available to the public and sold as mulch or a soil conditioner. And it's also used for making topsoil. About 10% of their screening of the amendments go back into the process. The composting facility for this one, because it's fairly large, cost between $10 and $15 million, including buildings, lands, significant infrastructure to support the composting facility. And it costs about $1 million to operate. Normally, an advanced treatment process should allow about 40 to 50% of the overall capital to build larger digesters, and a further 40% for composting, operation. The compost facility is about 10% of the capital cost of the Moncton facility, and much less than the operating costs for digesters. The staff consists of about 2.5 people, and they're responsible for hauling the sludge from the plant to the site and all processing. And then they do hire some additional staff in the spring and summer to handle any customers loading, etc. So the other success story is Medicine Hat. They've got some different challenges. They produce about 10,000 tons of wastewater, and they use a windrow system. They only produce Class B compost, which is fine for them. But their key is keeping the material out of the landfill to extend the life of the landfill. And they provide a beneficial use for clean wood, which is chipped and is also diverted from the landfill. And the composting facility also reduces the potential for landfill gases, like gas production. And they they space challenges with active composting due to daily delivery of materials. There's little market in their area for finished compost. So it'll end up being used as a final product during the landfill closure, as there's no other good on-site soils available for the final cover and reclamation of the facility. And they feel that any challenges are easily offset by the benefits of keeping material out of the landfill. The 2 systems I've talked about already require a fair bit of land, but there are other systems that don't require as much. So Sun Peaks has an activated sludge treatment process, and they realized they couldn't afford to ship their wasted biosolids to another facility for additional treatment. So after investigating both in the box and out of the box solutions, Sun Peaks ended up selecting an in-vessel composting system. After some trials and tribulations, the system continues to work like a hot darn, and composting was definitely the right system for Sun Peaks. So a few pictures of the system. The overall system is made up of the processing building, where you see the 3 containers sitting out in front. The mixing bin, control systems, and loading conveyors are all housed in that process building, which is about 60 feet by about 80 feet. The air delivery system feeds the top and bottom of the containers based on the temperature of the biomass. And the wasted air from the filled containers is used to heat up a newly loaded container and then vented to the odor bed. You can see it under the snow with a blue arrow. And they also have a curing building, a roll-off truck, and a chip storage building. So what were the capital investments for this project? The initial system cost about $650,000, and the additional works have been added over the years. Sun Peaks will be doubling the capacity of their system for less than $350,000 this year, and their expansion will enable a second location to be constructed, and it will include air and temperature controls, blower, and 2 more containers, with 2 being added at a later date. If budget allows, the cover building for the finished compost, as well as a bin for the roll-off truck to move product around the site. And this is well below the cost of a single digester, either anaerobic or aerobic. And to further control costs, the biobed is a passive system using spent compost, and it definitely deals with any off-gassing that happens. As the facility is located at the entrance to the community, if along the main road, if there is any odor issues, council would be the first one to hear about it. So to give you an idea of what it costs to operate this system, the total expenses in 2018, which is the last year I have numbers for, was about $100,000 a year, of which half was due to labor. The existing wastewater operators also perform composting duties as part of their overall treatment process. You'll notice that the cost recovery is a 0. So the Class A compost is used within the community to regreen boulevards, grow some vegetables, help new developments amend their landscaping soils to keep plants healthy and happy. And while council would love to see this great media sold, in reality, Sun Peaks only charges for the time to load large trucks. They have a customer designated pickup point where all you need is a shovel, some buckets, and a bag to load and take it away in your vehicle. It's great to see the bulk of the compost used throughout the community and helps to contribute to Sun Peaks' overall sustainability goals. To add to Sun Peaks' challenge, they practice water conservation to the point where their per capita demand for water is 215 liters per person per day, almost half of the Canadian average. So when I talk about the fact that Sun Peaks only produces about 500 cubic meters of 22% dewatered sludge, based on wastewater flows of 220, it's the fact that the wastewater is much more concentrated. And they do have, it's not we anymore, they do have lots of compost available. The bottom picture is what we produce on an annual basis. So as an industry, we have done a really poor job in dealing with the benefits of composting and public perception. It's okay to have a field of cows, sheep, chicken, etc. manure composting, but not for anything that uses human waste, which is strange because people have been collecting night soil for centuries to use in kitchen gardens and farmers' fields. Or is it today that so many of us are taking things that we shouldn't be and flushing them out every time we use facilities? So how do we fix this negative public perception? Education. It's important that we change the statement. I've made up my mind, don't confuse me with the facts. And the only way we're going to do that is to get out in front with the message that composting is good for the environment. So a little plug here. The Composting Council of Canada is working on a multi-year education initiative to educate the public on the benefits of composting. If you have any ideas or can help us, please touch bases with us. So what do I hope you can take away from this session? We're going to all have to meet tighter wastewater discharge requirements in the future. So start looking at the options that might work in your facility. These options don't have to be engineered right now. They just have to be added to the list. Look at other facilities that are near you that may be working on or have solved the problems of solids management. Talk to other operators about their tricks and traps. Learn from the failures as well as the successes. Start working with senior staff to educate them on options. So when the RFQ goes out for consulting engineers, you can give them the right directions to look at or for what to look at when the time comes to write the check. After all, the best treatment facilities are where operators are involved in the design development process as well as the implementation. I can't tell you the number of times that an engineer has proposed something that wouldn't work in practicality, and it got changed in the design process well before construction, much cheaper than after the fact. So thank you very much for attending this session. I hope we've intrigued you, and if you want to learn more, visit www.compost.org for more ongoing learning opportunities. And our virtual annual joint conference partnered with Ireland's composting organization is coming up at the end of September. And we've scheduled future webinars on different aspects of composting. And don't forget, these webinars are good for EOCP and CEUs. Thank you. Any questions?
We do have a couple. I think Lawrence Beaslings has just sent a link across the chat to the NIMO's proposed biosolids facility. That's not really a question. That's more of a
Bragging.
yeah, I guess so. Bragging. There you go.
Hey, Pat, it's Jenny. There was a quick question from Stacey Bell, just wondering if composting was going to be part of the facility classification. The answer to that, EOCP redid their classification models back in 2017, as most of you be familiar with. So solids management is in the facility classification model currently. It's a very, very small component of that. So under transport and disposal, yeah, there's 2 points awarded for disposal to an offsite landfill and 3 points awarded for biosolids compost or land application. So it's there, but it's not...
It's not a digester.
That's right. It's not a major component of the... It would not affect your classification drastically at this stage, and we don't have any plans to make changes to it in the near future.
Perfect. Thank you.
Do we have any other questions, Jenny?
It looks like, yep, there's another question here. Have you ever looked at the compost facility that Squamish and Whistler use in the Callahan Valley? I'm not sure if that's is that a question through to Pat?
Yes, we actually, when we were going through at Sun Peaks, looking at the pros and cons and the in the box and out of the box solutions, we definitely looked at Squamish and Whistler because they have the same issues as Sun Peaks does, which is heavy flows in the winter and fairly minimal flows in the summer. So the bulk of the biosolids production is going to be in the winter, which of course is your wettest, coldest temperatures. And that was one of the reasons why we went with an in-vessel system, because it doesn't make any difference what the outside temperatures are.
Great, thank you, Pat. Not seeing any more questions across the chat right now. Keep sending them in if there are any, or via email. We've got a few more minutes here, but I'll pass it over to Jim for a couple final remarks.
Yeah, I want to thank you, Pat, from the EOCP for your presentation. I enjoyed it. I do agree. The education is a big part of the composting process. You have to convince people, and I know there's projections out there now that phosphorus is becoming a very limited product in the world, and as it's mined out of the ground, it's going to make it very difficult to regrow without that fertilizer. And I think it's a shame to see biosolids being burned or destroyed in a non-recyclable way, if that makes sense.
Mm-hmm. We've just got another quick question that's come in. Arena asks, we are looking into a new facility in the Lower Okanagan Regional District of Okanagan Smokemean and would like to have some more info about required certification for compost for operators. What is needed at this point?
I can answer that, Jenny.
Yes, please do. Thanks, Pat.
Okay, so Right now, the only province that requires a compost operator to be certified is Alberta. But there is national certification available through the Compost Council of Canada. And there's a number of trainers that are available in BC. So it's a 2.5-day course and then a 3-hour exam to reach your level 1. And then you, a certain amount of operating time you need, and then you can write a level 2. There's only 2 levels for composting at this point in time. And there is a requirement to have continuing education credits to keep your certification for the Compost Council of Canada. And it's the Alberta standardized on their the Compost Council's training and exam to be able to require their certification. So it's something that is across the country. And I mean, it's going to be required at some point in time, because we've seen in the past where you have someone that's not trained and not understanding the repercussions of a well-run composting facility, and all your neighbors end up with complaints about odor issues and whatnot. Whereas if you understand the issues around composting and how you can maintain the composting system without producing a lot of nasty odors, then it's a lot better to go that way. So.
Great. Thank you, Pat. We've got a couple more questions coming in. So Chris asks, how did you get around liability with having public be able to come collect product on site?
They're actually, the public area that they pick it up is, let me see if I can go back. There we are. Sorry. There is actually by the TNRD's waste transfer site and the propane storage facility. So it's Class A at that point in time. It's been through all the pathogen reduction, the vector controls, etc. So it's no issue of picking it up. It's no different than going in the bush and getting dirt.
Okay, great.
So they're not actually within the facility. The picture below is within the facility and guarded gates, so that we we only load from there large trucks, and those are controlled. So it's not generally the public wandering through. And we post the results, Sun Peaks posts the results, which is that sign of the Class A facility, the range that all the nutrients, the foreign materials, etc. And Sun Peaks has a very good pre-screening in their headworks, so we don't end up with any foreign objects in the compost facility.
Great, thanks. So one more question here. Ben asks, how many metric tons can one Sun Peaks in-vessel composter container hold or compost at a time?
Oh, God. Okay, the container is 10 by 10 by 20. So we generally fill it full of a mixture of probably 50-50 biosolids. They're about 22% solids, and wood chips, which we import from Merritt, believe it or not. And so I'm not sure how many metric tons that would be. It's a container. I could probably get the answer. We'd have to put it through a weigh scale, which we don't have on the mountain.
Okay, thanks, Pat.